Hi and welcome back to a new video. Again today AMD Zen 5, this time the 9950X 16-core CPU. I spent the previous days testing the CPU, and before we get into my results I can tell you that my results are definitely questionable. At least, I mean, sometimes I'm looking at the results and I'm not sure what is going on, and that's what I want to just tell you up front. But I also talked to other reviewers and some of them had the same kind of weird behavior with this CPU, not meeting the performance expectations that we have in specific use cases. Everything that I tested with AMD, so every AMD CPU was tested on the same platform. So same motherboard, same memory, same OS, even though in between I even refreshed the OS, so I made a clean and new install of Windows 11, installed all the games again, just to double check, but the performance again was not as what I expected. So that didn't change anything for me. I even checked if the application or the game is running on the expected cores, but that was also the case. I'm testing with FPSmon, so I can always check while the game is running if the application is loading the cores with the high clock. So for example, like in Counter-Strike 2, I can see that the cores, the high-speed cores are running at like 5.5 to 5.6 gigahertz, and that these are also the loaded cores. I even went that far that I used Process Lasso to put the application just on one CCD on the high clocked cores. Didn't change anything. From my perspective, it also doesn't really solve any kind of issue if I'm running tests until we see a good result. For example, that's something I learned in my studies. Every test result is a test result and you cannot simply just exclude it from your results. So if I'm running 10 times the same benchmark and 9 out of 10 it's a terrible result and 1 out of 10 is good, then I'm definitely not just putting the good one here and saying, okay, now it's meeting the expectations. Because then I would neglect 90% of the results which might not be good. And I think for you out there, you will probably just do the same. I mean, you will assemble your system, you will install Windows 11 and the games or whatever you're gonna run, and you might face the same performance issues. So yeah, I just wanted to make that clear that, yeah, the results are what they are, and yeah, they are partially confusing. This video is powered by Seasonic with their MagFlow fans. These non-RGB fans combine both a low noise level and at the same time high airflow. In addition, they come with the perfect daisy chaining cable management system. Depending on your requirements, you can connect a different amount of fans directly with each other. For example, 2 or 3 fans for water cooling on a radiator. The fans are held together with a magnetic system which is extremely strong and also electrically connects the fans. With additional adapters, you can extend this even further. So for example, 2 fans on top of your PC for the AIO and a 3rd fan as case exhaust fan. Find out more about Seasonic's MagFlow fans in the description below. Before we get into my results and the benchmark data, we just look at Cinebench R23 first. I also want to highlight that in this condition, the CPU is currently already delidded, running with liquid metal and a different heat spreader. I didn't want to do it originally at this point in the video, but I had to to test something. And here we have about 41,300 points, so that's a little bit above what you usually have stock, at least for me. Probably because it's also delidded and then runs from my testing about like 100 megahertz higher than what you have in stock condition, because it stays slightly colder and thus is possible to boost a little bit higher. So here you can see it's limited by about 200 watt in power consumption, which results in fairly low temperatures. Without delidding, it was maybe like 5 degrees Celsius higher. So there was not a huge difference, at least in this state, talking about just running an AIO and basically just replacing the IHS and replacing the indium solder with liquid metal. But you see about like 4.8, 4.9, that is the multi-core clock that you have in the stock condition without opening up PBO. In Counter-Strike 2, as you can see, I made sure that always the right cores are getting the load, as I said before. So on the left side you can see that the majority of the cores is between 5.5 and like 5.6 in Counter-Strike 2, and that's also the cores where the load is at. And the cores below, where you can see a load of maybe like 4.2 to 4.3, are the ones without any load. So it's definitely assigned to the right cores. I tested the CPU in 3 different scenarios. So the first one is just a pure stock condition. The second one is with OpenPBO, which is mostly relevant for multi-threading applications because any kind of gaming application will not get to the 200 watt limit. And the third one is a result of the Tech Power Up article from the weekend where they tested 9700X with disabled SMT, where it gained a little bit of performance in gaming. So I also did that because at a specific point, I was like, okay, maybe there's something that can tweak the performance, so I also added this as a third benchmark. Starting with Cinebench R23. And as expected, the CPU is delivering in multi-threaded applications. We can see a 10% performance increase over the previous 7950X, while it's also consuming 10% less power, which is a result of the more restricted power limit of only 200 watt. So this increased the efficiency. You can decrease the efficiency if you want to by disabling SMT, which doesn't really make a lot of sense for Cinebench, and it will decrease to 31,000 points. If you unlock PBO, you can increase the multi-threading performance quite a bit to 44,600 points, but it also increases power consumption to 290 watt. Continuing with HWBot X265 benchmark, which is H265 encoding, so video encoding. And I want to highlight that for whatever reason, my 1400 KS is extremely terrible when it comes to performance, simply because this benchmark requires HPAD to be enabled. And whenever I do that on my 1400 KS, it's really buggy. Like the OS is slow and the performance is just not there, but it is what it is. Very similar as in Cinebench versus the 7950X, we can see about 10% more performance and at the same time about 10% less power consumption on the 9950X. Again, you can get extra performance if you disable PBO or open up PBO, and if you disable SMT, you will decrease your performance quite a lot. So again, in multi-threading, definitely not recommended. With Remnant 2, we are starting into the first gaming application, and here the 9950X is doing quite well. And it's mainly because Remnant 2 can make use of a lot of cores, and the more cores you have, typically the better this game performs, at least when it comes to the 1% low FPS. As usual, all the charts are ranked and sorted by the 1% low FPS, because from my perspective, it just makes the biggest impact on your subjective gaming experience. Doesn't really help you if you have a huge amount of average FPS, and if the 1% lows or the low FPS are really bad, it will still not feel smooth. And as usual, in blue you can see the power consumption in gaming. So back to Remnant 2, the 9950X is very close to the 7800X 3D, at least in the 1% low, but is a little bit more behind on the average FPS. It can't quite beat the 1400 KS though, which is still, at least in my scenarios, the best in this game. Disabling SMT in Remnant 2, not recommended. As I said, it can make use of more cores, so as you can see, it decreases performance here, while it even increases power consumption. Interesting though, if we look at the PBO scenario, so with OpenPBO, the CPU only consumes about 3 watt more, but it's delivering about 2 to 4 FPS more. So just percentage-wise, that's not even too bad. And this case with OpenPBO is quite odd, especially because in the stock condition, the CPU is still far away from the 200 watt. And I mean, PBO is defined by those 3 different values, and all those 3 values were not met, like were not exceeded during the gaming scenario. So opening up PBO, to me, it doesn't make sense. Still, it helped. I could reproduce it every single time it helped, and I have no clue why. I could see the same behavior here in Assassin's Creed Mirage. The 9950X with unlocked PBO will again gain about 2 to 4 FPS, which is about 2 to 3% versus stock. And stock, the 9950X is about 3% faster than the 9700X. Assassin's Creed Mirage could benefit a little bit by disabling SMT. We see about a 3% performance increase, but what's kind of interesting though is that the power consumption increased by 20 watts. Just for getting 3% additional performance. So you get more performance, but efficiency-wise doesn't make a lot of sense. And now we're getting to the more problematic benchmarks, starting with Cyberpunk. And here my 9950X performs with about 82 FPS in 1% low and 156 in average. And that is behind a 7950X, so the previous CPU. It's only by 2%, but that definitely shouldn't be the case. Looking at the power consumption, I can't find the difference between the 7950X and the 9950X. Unlocking PBO also didn't really help anything in that case, that's just measurement tolerance. Disabling SMT though, a bad idea. For me, it increased power consumption and decreased performance, so not recommended for Cyberpunk. Now changing to Valorant in 4K and max details. The 9950X can beat the 7950X in this scenario by 8%. It's still odd though, because it's still behind the 9700X, and that just made me question. In Valorant, the 9950X was clocking higher than the 9700X, but it was having less performance. And I could reproduce that every single time. I'm not sure why this is the case. I mean, it should be the same cores, right? Just more of them, just 2 CCDs. Maybe that's related to that, but I have no explanation why, with a higher clock, the CPU still performed worse for me. Unlocking PBO, interestingly, increased the performance quite a bit, from 476 in 1% low to 537, while the power consumption only increased by 3%. That is just so strange. Now to the weirdest result, Counter-Strike 2 in 1440p, and I had a huge amount of problems with the 9950X in this game. Stock condition 9950X on the last rank, even behind a 7600X. Unlocking the PBO didn't really make a change to the power consumption, but definitely increased performance again. Still, and even in this condition, it's less performance than what I expected from the 9950X, because it's still behind the 7700X or even the 9700X. So yeah, I don't get it. And that was also the point for me where I reached out to other reviewers to double check if it's just me or if somebody else is also seeing weird performance. And then some said that they're seeing expected performance numbers in some cases and not expected in others, but nobody, at least from what I could see, only had good results. It was like very mixed, and I'm not sure what the reason for this is. And also earlier in my video, I already said, I'm not a friend of just testing until it looks good. Like, this is those are the numbers I was getting out of my applications, out of my games, and that's where we are. Maybe that's also the reason why AMD delayed the launch for those CPUs. Maybe they expected to fix the performance in between somehow, but I can tell you, I mean, I'm still running the same BIOS, the same chipset as for the 9700X, so in the meantime, for me, nothing changed. Yeah, I don't know. Talking about things that are not working out. A few days ago, again, Tony Yu was showing a delidded Ryzen 9000 CPU. We already covered this in the last video about the 9700X, which he broke. And then again, he showed a broken 9950X. I'm not sure again what he was doing. And I was a bit worried, to be fully honest, because I mean, I was deleting the CPU in June and it was working fine. And he so far showed 2 deleted CPUs and both of them were broken. So I decided to also delete my 9950X today, this morning. So let's check this out, this footage. We will start with my footage from June 1st with this 9950X AMD engineering sample. And I just used the Ryzen 7000 delidder with no changes, same process, moving the slider back and forth. It took me about 10 minutes to get the heat spreader loose. And then underneath you can see the indium solder as previously, same as on Ryzen 7000. Already there in the direct comparison with this 7700X that I had with me, I couldn't see any kind of difference. I first started measuring with this micrometer to get the PCB thickness of the 7700X, which was measured with about 1.32 millimeter. Repeated the same thing with the 9950X, and there I could measure about 1.34 millimeter, but that's just like production and measurement tolerance. You could say they're equal. Then proceeded to clean the CPU dies to be able to also measure the die height. For this measurement, I set the micrometer to 0 on the PCB, and this allows to easily measure the chip height. I had about 0.87 millimeter on the 7700X and about 0.85 millimeters on the 9950X. And again, that should be within measurement and also production tolerance. So again, both can be considered equal. That's also why I proceeded mounting the 9950X with our direct diaphragm V2 in this AM5 motherboard. Again, as with the X3D CPUs, the version V1 is not compatible with a Ryzen 9000, but it's something we already posted on our Grizzly website a few weeks ago. I then proceeded to test the CPU with our high performance heat spreader simply because the IHS shares the same structure on the bottom as our micro direct die water block, and this way I can easily determine the compatibility of both. In the end, I did a quick temperature check, which looked alright, nothing special really. It was only 5.2 GHz overclock on this 9950X. and it's like a 280 AIO, but it didn't really matter when it comes to temperatures. I just wanted to see if it works out. And it was also an engineering sample CPU that was not able to clock as high as a retail CPU, but that was just the first mechanical validation. Before we start with the delidding process, I'm now running the 9950X with OpenPBO, and the CPU boosts between 5.1 and 5.2, I would say, as you can see here. And also it's now thermally limited. So some cores are reaching, as you can see here, about 95 degrees Celsius, and that's mainly because you can see package power is just below 300 watts. So that's unlimited what the 9950X can do. And even if I would proceed with manual overclocking, I could fine-tune this a little. So maybe get 50 megahertz to 100 megahertz maybe extra with a slightly lower V-core and adjust the clock a little bit. But that's basically about it. And that's where I just want to start from. That's the starting point, about 95 degrees Celsius with a 3060 AIO, just below 300 watt and between 5.1 and 5.2 gigahertz under load. And there we have our 9950X stock condition. And we now put the CPU into the delidder according to the triangle that you can also see on here. Slider only fits in this direction. Well, basically two, you could rotate it, but it's a symmetrical part, so it wouldn't matter. Now fix everything with the included screws, and then you can start, for example, with that one, pulling the slider in that direction, and then just move it back and forth, probably like, I don't know, 50 times, sometimes also up to 100 times, might take you 15 to 20 minutes until the IHS becomes loose. And especially on the first move, it will take quite a bit of force because it's not only releasing the indium, well, slowly, but also the glue that keeps the IHS on the PCB. That sounds amazing, right? At a certain point, after you moved it maybe like 4 or 5 times, you could also move to a drill. I also personally did that, I don't know, like 10 times before, at least on Ryzen 7000 was never a problem, because it just speeds up the process a lot if you can move it back and forth. But yeah, I guess I see you in 10 minutes. So far, I moved it 28 times. It's getting a little bit easier, but still, you can see I cannot move it with my hands yet. And that will be the point once it's really done. So if you cannot move it with your bare hands yet, then just don't take it out yet. After 51 times, I counted it, you can see I can easily move it back and forth. First look, just as usual, no change from Ryzen 7000 to me. So second 9950X just worked out fine for me. Now would be the time to scrape off the glue, remove the indium solder. Now I'm using this scraper tool, which we now include in all the delidders, to scratch off most of the indium. And once the majority is gone, I will just put liquid metal on to release the rest. And this is also the state that's basically the most dangerous. So if you are not careful enough and you scrape over an edge, then you can break off parts of the chips and damage the chips permanently. So that's something where you have to be extremely cautious. Now remove the glue. And also again here you want to be extremely careful not to damage any of the SMDs or scratch the PCB, because it's basically a successful delete and you don't want to ruin the CPU in that state. Now a little bit of liquid metal on top to remove the rest of the indium. The gallium inside the liquid metal will then alloy with the indium, and this way it's quite easy to remove. I will usually just leave it on here for like 15 minutes and then swipe it off. That's how it looks like after the first cleaning step. There is still some indium left on the bottom right CCD, as you might be able to see. And that's something you definitely have to remove. So I will just do the same step again, scratch off what I can see here, add a little bit of liquid metal, clean it, and then it should be done. If you remove it, use a wet cloth, ideally with acetone or isopropanol, and just wipe across. Just take multiple ones and then you should be able to get most of the liquid metal removed as quickly as possible. And here we have it, second successfully delidded 9950X. Still can't see any kind of issues. What could go wrong here? Well, there are things that could go wrong, but at least in this process, the way I did it, nothing went wrong on 2 CPUs. As you can see, no cracks, no missing chips. And now, while we're already at it, I will just perform some measurements on the CCDs and also on the PCB so you can see where the differences are. We will first start with a Ryzen 7000, in that case a 7900X. And we have a chip size of about 10.4 by 6.7 millimeters. And the I/O die has a size of about 9.7 by 12.6 millimeter. And here we have the I/O die of our 9950X. It's just exactly the same dimension, also 9.7 by about 12.6 millimeter. The CCD is slightly different when it comes to the dimension, but the overall area is pretty much the same. So it changed from 6.7 and 10.4 to 7.7 and 9.1 roughly. But the overall area is about the same. I will now mount the CPU again, just with the high performance heat spreader. So effectively the only thing I'm changing is the indium solder and the IHS, because everything else, the AIO and also the thermal paste on top of the heat spreader will be the same. And just to also cover this, I saw some speculation about this online, but the IHS is basically the same. Same goes for the indium solder, there's no change. CPU already back in the socket, removed the SAM, we'll place the IHS on top. System up and running. I already managed to put thermal paste on my new AIO, which is great. I'm still supposed to do a review about that. It's a new AIO from Trikes. Doesn't really matter, but I want to show that if you look a little bit underneath, you can spot the upgrade heat spreader, the high performance heat spreader. And here you can see the system successfully booted with the 9950X. One thing I want to note, I'm not sure what is the reason for that, but with this new BIOS and loading Expo 6000, sometimes it takes like 3 minutes to boot. Insane. Same condition as previously, just configured PBO to the max, loaded Expo, and that's it. What we can see now is a slight increase in the clock to about 5.3. It still is very hot, that's expected, still 95 degrees Celsius. But we should also see that on the power consumption, so slightly higher, it's like 305 watt now, and that should give us a little bit extra performance. Again, not sure what was going wrong with Tony Yu's results. I mean, I so far delidded 2 9950X successfully, and as I showed you, there is no difference to the 7950X. Like the I/O die is the same size. Why would it suddenly break apart while it works fine for me? There's only a tiny difference in the CCDs when it comes to their just size, but the area itself is also mostly the same. Position is roughly the same. PCB height is also the same, so yeah. So from my perspective, Ryzen 9000 delidding just the same as Ryzen 7000. I just can't see a big difference. For delidding, we will have a dedicated video coming, also covering the 9700X delidding, which should be interesting, also overclocking wise. Then we will also do the 9950X again with direct eye water block, custom water cooling, see what it can do. When it comes to the stock condition of the 9950X, I don't really have a conclusion, because I want to see the bigger picture first. I want to see if maybe my results are out of line, or maybe the CPU is out of line. It's so strange to me that I just don't want to do a real conclusion right now. Just want to see, yeah, what's going on, and then maybe we'll do a follow-up. If my testing was completely out of line, then definitely have to retest and find out what was going on. But I just want to see the bigger picture first before just saying anything that could be wrong. All right, I hope you still enjoyed it. Thanks for tuning in. See you next time. Bye-bye.